Hi everyone, I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about random process and its classifications. Random processes are essential in various fields. They involve unpredictable sequences of events or values, playing a critical role in statistics, signal processing, and risk assessment. Definition: random process is nothing but collection of random variable with time function. Random processes exhibit inherent variability, making them difficult to predict or model precisely. They are characterized by stochastic or random behavior rather than deterministic pattern. Events within a random process are typically independent with no influence over each other. Classification of random process based on the sample space and time space, which will be classified into four categories: discrete random process, continuous random process, discrete random sequence, continuous random sequence. In continuous random process, both sample space and t values are continuous. For example, consider a temperature at a place in the interval 0, t. Here the temperature value, that is sample space, lies between 0 to 100, and the time between 0 to t, which is also continuous here. In continuous random sequence, a sample space is continuous and time value is discrete. For example, consider a temperature of a place at the end of the nth hour of a day. Here the temperature value lies between 0 to 100, it is continuous, and we calculate the temperature value at the end of the first hour, second hour, third hour, like this, which is discrete. So this is continuous random sequence. In discrete random process, the sample space is discrete and time is continuous. For example, if we consider the number of telephone calls received in the interval 0, t, here the time interval is 0, t, which is in continuous case, and number of telephone calls, first call, second call, third call, which is coming under discrete. Next, discrete random sequence. While throwing a dice, um, we are having the sample space values are 1, 2, 3, 4, 5, 6, and tossing the throwing a die first time, second time, third time means which will be discrete. So here the sample space s value and time value both are discrete, means which is coming under discrete random sequence. In homogeneous versus non-homogeneous, homogeneous process have statistical properties that remain constant over time space, while non-homogeneous process do not. Stationary and non-stationary random process. In stationary process have statistical properties that remain unchanged over the time or space. In non-stationary process exhibit statistical properties that change over time or space. Example of stationary random process: Brownian motion. A classic example of a stationary random process often used in physics and finance. Radio noise. Noise in a radio communication is a stationary random process with specific statistical properties. Example of non-stationary process: market trend. Stock prices often exhibit non-stationary behavior due to changing market trends. Climate data. Long-term climate records exemplify non-stationary patterns caused by environmental changes. Importance of random process in various fields. In finance, stochastic modeling for risk assessment and investment analysis. In telecommunication, random access protocols and signal processing. Coming to the conclusion, random processes are fundamental for understanding variability and uncertainty in complex system. Applications. They find application in diverse fields ranging from finance to engineering and environmental sciences. Thank you.